What's going on, everybody? This is Mr. Diamond, and this is going to be the video of an example of balancing a basic solution. Let me turn up the volume. Get this a little closer. Maybe that'll do it. I don't want it to be super quiet. Anyway, what we have here is an example. AG plus ZN2 plus gives AG2O plus ZN, and this is in a basic solution. So we're going to follow our step-by-step procedures. First things first, we're going to go ahead and figure out our oxidation numbers. So we have AG, we have ZN, and we have O. Although O is only on this side, and we know it must be a -2. So we can tell AG and ZN are going to be our two things that we're going to use, because O is only on this one side, which makes sense because it is a basic. Remember, if you have an acidic or a basic solution, sometimes you have to deal with there not being stuff on one of the sides. Over here, AG is by itself, so that's 0. ZN's by itself, so that's 0. ZN has a 2 plus, so that's a 2 plus or a +2. And AG has two of them with one O. O is -2, so that must be a +2. All right, we hopefully are feeling pretty good about that. We've been doing that a lot this chapter. Now we're going to go on and come up with our half reactions. So AG is going to become AG2 plus. And I actually am worried about space, so I'm going to scoot this one a little bit more over. So we have ZN2 plus, sorry, not AG2 plus, becomes AG2O. And then zinc ZN2 plus becomes ZN. All right, so that was this step. Then we add our electrons because we have to account for them. In this case, we need to add 2 electrons. Oh, sorry, we don't worry about the electrons just yet. Let's go ahead and let me click over here. Let's go ahead and get our H's and our O's as we need to do. Remember, we add electrons at the end after doing this. I'm actually recording this Monday morning, so we had a little bit of a gap. I had to click back and look at the notes. So this one doesn't actually need any H's or OH's because there is none to account for. But this side has an O, so we are going to have to add an H2 over here. Now it's 2 H's over here. We're going to have to add 2 H pluses over here. And then AG, we're going to need to put a 2 right there. Again, you do actually have to make sure all of your elements are balanced. Next step, we have to add electrons as needed to each side. In this case, we want our charges to be equal. This side has a total charge of 0. This side has a total charge of +2. So we're going to add 2 electrons. This side has a charge that is neutral. This side has a charge that is +2. So we're going to add 2 electrons. So far, exactly like acidic. Remember, for basic solutions, it's only at the very end that you do one little step that's slightly different. Next, do we need to multiply? No, we do not. There's 2 electrons on each side. Then we can just go ahead and add our pieces together. So we've got H2O plus 2Ag plus 2E plus ZN2 plus gives Ag2O plus Zn plus 2H plus 2 electrons. Now, before we go further, we want to cancel pieces out. I have 2 electrons on both sides. That's the only piece that I've got to cancel out. Now, because it is basic, we do not actually stop here and simplify that out. Because it is basic, what we're going to do is we're actually going to add OHs, we're going to add hydroxides to both sides to cancel out any H's. So in this case, there is 2 H pluses. So I'm actually going to add 2 OH minuses to both sides. And this is one of the cases where you do have to do the stuff to each side to get it to work out. Okay, next what we're going to do is we're going to combine our H's and our OH's, and then we're going to rewrite this and cancel it again. So I have 2 OH minuses. I'm going to leave the gap because that looks like 20 to me. plus H2O plus 2Ag plus Zn2 plus gives Ag2O plus Zn plus, and now I'm combining these together to make two H2Os. And notice I have pieces that cancel again. This H2O is going to disappear. One of these H2Os is going to disappear. And I'll be left with my final answer, that is 2OH minus plus 2Ag plus Zn2 plus gives us Ag2O plus Zn plus H2O. So up to this point here, it's the exact same process as we did with our acidic solution. Then the only difference is you check, okay, which side has my H pluses? I'm going to add that many OHs to both sides. That'll convert these to waters, and then that's going to cancel out waters that are on the other side and leave you only with OHs. Now, if you notice, up here in our original, there was one water and two H pluses, and down here there's two OH minuses and one water, and they've swapped sides. You can use that as kind of a shortcut. If you solve it as an acid, you know you're just going to flip the sides and convert H's to OH minuses. But if that actual step or that solution doesn't make sense to you, then you could just do this the long way, and it'll work out every time. So that is how we balance a redox reaction in a basic solution. That's the last thing for this chapter. So if you made it this far, great job. Hopefully you're feeling pretty good about this stuff. If not, shoot me an email or ask me questions in class. Otherwise, this is Mr. Diamond signing off. Have a great day, everybody.